Hey guys! In order to make sure that you can be as successful as possible on your MLQ and just in 8th grade math moving forward, we really need to take a day to review all of the different laws of exponents and the different things that happen when you have exponents in an expression. So let's take a look. Today's going to be a big practice day. Take a minute, pause the video, write review exponent laws, get this first example, and just be ready to follow along with me because we're going to go boom, boom, boom through a bunch of examples so that you can get to practice. So pause the video now, copy those things down. The first type of exponent law that you need to see is the power of powers law. A power is just simply an exponent. I love this law because I have two exponents squished together, and in math, squished together always means multiply. So all I have to do is rewrite my base of 3 and then multiply my exponents. 2 times 4 is 8, so this is the same thing as 3 to the 8th power. Let's look at another one. 9 to the 5th squared. These two exponents are squished together. Squished together in math always means multiply, so I'm going to keep my base of 9 and multiply my exponents. 5 times 2 is 10, so it's 9 to the 10th. 4 to the 4th to the negative 3rd. Same thing goes. My exponents are squished together, so I'm going to multiply them. Keep my base of 4, and then multiply my exponents. 4 times negative 3 is negative 12. Because it's like you borrow $3 from me 4 times, now you owe me 12. That's the first one. Powers of powers law. Another one you're going to see is just the basic multiplication law. What I want you to do is go ahead and draw a little line in your notes like this. And down here, I want you to write maths. Make sure that your paper looks exactly like mine because all of these review examples are going to help you when you're practicing. Maths simply means when you have a common base and you multiply, you add your exponents. When you divide, you subtract your exponents. So in this problem, I have a common base of 3, and I can see I'm multiplying. So I'm going to keep my base the same, keep the 3, and then add my exponents. 3 plus 2 equals 5, so this is 3 to the 5th. My pen is your pen. Let's look at another one. 4 to the negative 2 times 4 to the 6th. I have a common base, and I'm multiplying, so I can use maths. When I multiply, keep my base and add the exponents. Keep my base of 4 and add my exponents. Negative 2 plus 6. This is what you are reviewing in math intervention this week, so remember, when the signs are different, find the difference. 6 minus 2 is 4, and then you keep the sign of the greater digit. 6 is the greater digit, so it's going to be, and it's positive, so my exponent is positive 4. Let's look at one wonky example, and then we're going to move on. This one looks kind of crazy because it has a fraction. Please make sure you copy this down. Hint, hint, you're going to see this again in your future. Something that we need to review is that negative exponents are used to represent fractions. I'm going to pull this whole thing out and move it over here so that I actually have a lot more space to deal with this problem because this one's super important. 1/4 times 2 squared. Okay, I can see that the base I'm working with is 2 because I have that here. I need to think, how can I break this 4 down using multiplication into 2's? Well, 2 times 2 is 4, so 1 over 4 is the same thing as 1 over 2 times 2. So my base here is definitely going to be 2, and I can rewrite 2 times 2 as 1 over 2 squared. So my problem I have now is 1 over 2 squared times 2 squared. I can't do anything with this yet because I still have a fraction, But I can rewrite this fraction using a negative exponent. I keep my base of 2. I keep my exponent of 2, but I make it negative. That gets rid of the fraction. So 2 to the negative 2 times 2 squared. Now I can multiply. I have a common base, so I rewrite my base of 2, and I can go ahead and add my exponents. Negative 2 plus 2, you borrow $2, then you pay me back $2. This is 2 to the 0 power. Let's take a look at one multiple choice example, then you're going to practice on your own. Okay, let's look at another one of these that has this crazy fraction, because I think this is actually going to be the hardest thing that you see. In this problem, I can see I have a whole number 4 as the base, so I'm going to try to turn this fraction into something with a base of 4. Now notice, there are a bunch of multiple choice examples here, and I haven't even looked at these yet because this is too crazy to even make any sense of, so I need to simplify this down before I even start looking at my multiple choice. So ignore the multiple choice and just be with me on this example. Make sure you have this copied down in your notes, and everything I write, you have to write. I'm trying to turn 1/16 into a number with a base of 4. So how can I break down 16 into 4s using multiplication? Well, 4 times 4 is 16, so I can rewrite my fraction as 1 over 4 times 4. Now, I just want to use 4 as my base with an exponent, and this is 4 times 4, which can be rewritten as 4 squared. So now I have 1 over 4 squared. The last piece that I just reviewed is that you can use negative exponents to represent a fraction. So you keep this number as your base, and then to get rid of this fraction, you make your exponent negative. So this 1/16 is the same thing as 4 to the power of negative 2. I'm going to bring down this other part times 4 to the third. Now that I have this simplified, I'm looking for one of my answer choices that's equal to 4 to the negative 2 times 4 to the third. Let's look. 4 to the third times 4 squared. This is close, except this 2 isn't negative, so this one can't be right. 4 to the negative 2 times negative 3. Nope, my 2 is negative, my 3 is positive. This can't be it. 4 to the 2 times 4 to the negative 3. I'm looking for 4 to the negative 2, and I don't have that here. I'm looking for 4 to the positive 3, and I don't have that here, so this is wrong. 4 to the third times 4 to the negative 2. 4 to the third, I have. 4 to the negative 2, I have. This is my answer. It does not matter that these two things were written backwards. I could rewrite this as 4 to the negative 2 times 4 to the third, and it's exactly the same thing. So that one's my answer choice. I'm going to stop talking. It's time for you to practice.